All right. We're going to, I want to show you how to enter the data into Desmos to be able to find the correlation coefficient. They showed you on slide 19 how to do it using a graphing calculator, but I want to show you how to do using Desmos. So go to desmos.com/calculator. And the first thing you're going to do is you're going to go ahead and enter a table, and they usually give you a table of data to, so I'm going to do, I'm going to go ahead and enter. If you hit enter, it just enters the, like all the X's together down the line, makes it a little easier to enter in. And then I'm going to go ahead and enter my Y's, 50, 70, 80, 82, 83, 86, 98, 97, 100. Oops. So once you have that entered, now we can need to enter, we're trying to get a, and you can zoom in and out to kind of try to be able to see your coordinates. It looks pretty, I mean, the line looks pretty steep. It's increasing, so we know our R value, our correlation coefficient, is going to be positive because the line's increasing. So now we want it to tell us what that is. It actually will give us the equation of the line as well, but let's start here. So we're going to do Y, and then you're going to hit the little underscore 1. Now, it needs to be in the first spot. So once you start to type it, you can drag it up so that it is in the first spot. If you put it underneath it, like wipes out your table too. So that's why I drag it up after I've started to type the equation. And then you need the little tilde, and the tilde is beside the 1. And then the equation of a line is y equals m and then x underscore 1. So mx. And now we're going to put our plus b. And then that's it. So you can kind of see we have this equation here of this line. And you've got points kind of on both sides. The correlation coefficient here in that little box at the upper left is 0.9005, and I'd expect that correlation coefficient to be pretty close to 1 because that's a pretty good fit for that data. It's a pretty good, that line is a pretty good, it's a pretty good descriptor of that data. So what you notice is the parameters it gives you, the slope. The slope is 9.2-ish. So, and our y-intercept is about 62. So if I had to write an equation for that line, it would be y equals 9.2x plus 62. So now you can make these points movable so you can see what happens if you have an outlier. So to do that, you're going to hold on this little green dot here. You can change the colors of your points if you want to, but I'm going to click drag, and so it makes those points, notice how the points kind of have a bullseye around them. So I could drag one of these, click off of here, I could drag one of these points and see what happens to that correlation coefficient. Because I have that outlier, it's really pulling it to the right, and so notice my correlation coefficient is like 0.6. It's not a great estimator. And then I could also slide it down. But you can kind of move it, and you'll notice that it is changing this coordinate here. So our original coordinate was 5 and 100. But I kind of like that because it helps me be able to see what happens when I have that outlier and I'm moving those points. So that's how you find your correlation coefficient. Remember, that's R, not R squared. And it also is giving you slope and y-intercept. So that should get you through everything that you need for, I think that 6.1 probably ought to get you pretty close on 6.2 as well. Now, with 6.2, it's actually writing that equation of the line. If I were doing this by hand and not using Desmos, I would choose 2 of the coordinates that on this line maybe. Maybe this is a good estimator and this one is a good estimator. And then I would use those 2 coordinates, find the slope, find the y-intercept, and write the equation. That's if I'm doing it by hand. So hopefully that helps. I think I should be able to see you on Monday, maybe 12:15ish. So have a great weekend, and I'll see you later.